Okay, thank you to those who have pulled out a piece of paper and have already started labeling their papers. It's called Factoring Day 2. You need your name, date, and period in the top right-hand corner. Remember, these need to be nice and neat because they go in your portfolio, and neatness is part of your grade. Okay, our essential question today is going to be, how does having a leading coefficient not equal to 1, doesn't equal 1, different? Oh my goodness, let me think here. It's been a long day. How does having a leading coefficient change how we factor? That's all it's going to change today, is having a leading coefficient greater than 1. The leading coefficient is the coefficient in front. Are you writing down, please? The coefficient in front of the greatest exponent. So if it's an x squared, it's the largest power. Whatever number is in front of x squared is our leading coefficient. How does having a leading coefficient? You guys know that this equal sign with a slash means doesn't equal. So not equal to 1 changes how we factor. Okay, I'll be right back up at the top if you need that. In just a sec. Here it comes. And, okay, our first problem is going to be, I used this one last time, let's use it. Example 1. 5n squared plus 24n minus 36. 5n squared plus 24n minus 36. Are you writing down, Gabe? Okay, we're going to factor this, and it's almost the same except for a no s in front of n squared, there's a number this time. It actually makes it a little more complicated. So I promise this box method actually makes the whole process so much easier. Because when I learned how to factor this, we just guessed and checked, and usually I get the numbers wrong. So what's going to happen is in front of our n in our factor, so say n plus 7 and n plus 8, in front of the n's, there's going to be a number in front of it. And when you FOIL it, or double distribute, it makes it so much more complicated. So the box method, super easy compared to other methods, which is why we taught that to you last time. Okay, so it follows the same thing. Inside, let me make this a little smaller. Inside the box, once again, as a review, the first term goes here, the third term goes here. That's the same. What's new is on the x, when we look for things to multiply, it's actually the first coefficient times the third coefficient, which last time we didn't care about that because the first coefficient was a 1. So timesing by 1 didn't change anything. And then we're going to always add to the second coefficient. Yes? No? Okay? So, let's do this problem now. Annabelle and Tristan S, would you both mind opening the door, though, so we can get some air? Okay, the first term's going to go in this top left corner. Okay, what goes in this top left corner? 5n squared. And then the third term goes in the bottom right. So, Jared, what goes in the bottom right? Thanks for saying negative. It is negative 36. Okay, so this is the same so far. Now here comes the change. We must take 5 and negative 36 and multiply them. So what is 5 times negative 36?
180.
Oops, I typed something really strange. Negative 180. Okay, and then we look to add always to the middle term, the middle coefficient. Okay, Alejandra, what's the middle coefficient? 24, positive 24. Okay, so when we have a leading coefficient that's not 1, the number we're looking to multiply to is a lot larger than it normally is. So we have to make our list and find things that multiply to negative 180. So when the number is larger, it's easy that we could miss it if we don't go in order. So I recommend starting with 1. 1 times what is 180? Negative 180. Negative 180. And then we discussed last time that we can reverse the sign and make it negative 1 times positive 180. Okay? Does 2 go into 180? So I'm going to stay in order so I don't miss it. Does 2 go into 180? 90. So negative 90 would give us negative 180. And negative 2 times positive 90. Okay, so we've done 1, we've done 2. Does 3 go into 180? You can think of 18. 3 times what number is 18? 6. So 3 times 60. Now in this case, we're going to have to make it negative 60. And negative 3 times positive 60. Okay, let's stop for a moment and just see if we have it. Because if we found our pair, then we don't need to keep going. Let's see. It has to add to 24. 1 plus negative 180. Does that add to 24? Nope. Does this pair add to 24? Next? No? No. But we're getting warmer. It's, if you notice, the sum is decreasing. Here is negative 179, but down at negative 2 times 90 is negative 88, so it's getting smaller. And then here we get 57, so it's getting smaller. So we're getting closer because we need to find all the way to 24. So we've done 1, 2, and 3. Does 4 go into 180? It does. Can someone find it for us? Negative 180. What goes into negative 180? 4 into negative, 180. Thank you. Whoever said that as a guy. Was that you, Alex, or someone behind you? Okay. And negative 4 times positive 45. Does 5 go into 180? Yeah. Okay. What's it going to be, Brianna? 5 times what is 180? Negative 180. What? Maybe. Let's see. Oh, you're really close. That's 170. So we need 2 more, so that would be 36. Negative 36. And negative 5 times 36. And let's see how close we are. What's 4 plus negative 45? Negative 41. What's 5 plus negative 36? Negative 29. We're super close. We need 24. Positive 24. So does 6 go into 180? Yes. 6 times what number is 18? Let's go with Sean. Sorry. 30. So in this case it'll be negative 30. And negative 6 times positive 30. Let's check this one because we're close. Do either of these add up to 24? Positive? Finally! This is just the hardest part of the whole thing. And eventually as you do more, you won't have to go 1, 2, 3, 4, 5 until you find it. You'll be able to get a lot closer, a lot quicker as you practice finding the pairs. So we have negative 6 and 30. Remember, those are your n's. Negative 6n and 30n. Those are your n's. Make sure you write in an n with them. It doesn't matter which one goes in which spot. They just need to be diagonally from each other. Okay, Phoenix, what's our greatest common factor in the top row? 5. Not just 5, though, Phoenix. Look a little closer. There you go. 5n. Okay, and how about Jessica? What's the greatest common factor in the bottom row? Okay, 6, because that one doesn't have an n. Right? Gabe? We'll see in just a sec. Gabe, in this column, 5n squared and negative 6n, what do they have in common? They both have an n. And if you look at the numbers, 5 and negative 6, the greatest common factor would be 1. So you can write the 1, but you don't have to. But let's check the sign. 5n times n, is that positive 5n squared? Okay. 6 times n, is that negative 6n? No. So this is where we go and put the negative in. Okay, and then the last column. Carlos, what's the greatest common factor for 30n and negative 36? What? 30 doesn't go into 36 though, because you have to be able to divide and come out nicely. So it's something smaller than 30. So you just think dividing. What divides into 30? And that same number has to divide into 36, or negative 36 in this case. What else can go into 30, Carlos? 6? Does 36 divide by 6, class? Yep, so that will work. Now let's check the signs. 5n times 6, is that 30n? Okay, and negative 6 times 6, is that negative 36? Susanna, she no. Those grades sounded like she was questioning it. I did that on purpose. Okay, so negative 6 times 6 is negative 36. So those are our answers. 5n minus 6 that we got right here. 5n minus 6. And on the top, n plus 6 because we found out it was positive 6. Okay, we're going to do one more. Practicing this factoring. There's a reason we spend 2 days on factoring, because it's a little intense. Okay, one more. Example 2. Please write down 7m squared minus 47m minus 14. Okay, then I would like you to try to fill in your box and your x, and then stop. Fill in the box and the x. You have still the diagram on the whiteboard over there of what goes where. Fill in the box and the x, and then stop. So you have your box filled in. Now fill in the x, please. Okay, hurry and fill in the box, please. Forgotten. Cynthia, what did you get for the top left? Seven m squared. Yep, that would be our first term. Raul, what did you get for the bottom right? Good. I'm glad you found the negative. It's not just 14, it's negative. Okay, Gustavo, now we take both of those, 7 times negative 14, and put it up here. So do you know what 7 times negative 14 is? Can you find it, please? Okay. And then Gustavo, which term goes here? Comes from here. What haven't we used yet? Negative 47. Okay, so we do a list. If I notice that this number is kind of a larger number, negative 47, to multiply it to a negative, we have to have one's going to be positive and one's going to be negative. So when we add them, they're going to be kind of far apart from each other. They're not going to be really close. So eventually you'll start seeing a connection to help you find these faster. So 1 times negative 98 and negative 1 times 98 should be obvious. Does 2 go into 98? Negative 98? 2 times what? Negative 40, I'm hearing it. Negative 49. And negative 2 times 49. And I think we've actually already found it. Which one is it? Tell me when to stop when I get to the one that adds to negative 47. Stop. Good. Good job, guys. So that one, thank goodness, came a lot faster than our first example. Okay, Lexi, can you turn around, please? And Hakeem, stop talking to her. So these are our n's. Remember to write them in with n's. To n negative 49, n. M. These are our m's. Sorry. Thanks for catching that. Yes, the variable should stay constant. Sorry about that. Okay, Jessica. In the top row, what's the greatest common factor? There is an m, but they both have a number, so look, there's a greatest common factor with the coefficient as well. What? Okay, so 7m. Because negative 49 divided by 7 works when we get negative 7. It comes out nicely. Jared? Because this only has one m to give, so it can't be squared. Okay. How about Brayden? Can you get the greatest common factor in the bottom row, please? Does 2 divide by 7? Okay, so it can't be larger than the smallest one, so it can't be bigger than 2. It is 2 itself. Okay, Dominic, what's the greatest common factor in this column? What do they have in common? Okay, Phoenix, what do they have in common? Just an M. Okay, and this last column, Junior, what's the greatest common factor for the last column? What divides into both negative 49m and negative 14? 2 goes into 14, but doesn't go into negative 49. 7, good, but is there a higher one? Sean?
I'll put in negative 7.
Okay, negative 7. Does 14 go into 49? Try it out. Does 14 go into 49? 49 divided by 14. No, it doesn't. So you just have to check. Sometimes it's the exact same number. Other times it's a smaller factor. So good, you got that right. Now let's check the signs. 7m times 7, is that negative 49m? No. So there's our negative sign. And 2 times negative 7 gives us negative 14. So we have our answer. 7m plus 2 and m minus 7. Those are our 2 factors. Okay, so same process as last time, so I hope this is helping to solidify it. We have an assignment on page 680 all the way through 682. Okay, some of you, thank you for putting it right in your phone, like I asked you to. If you have a planner or a phone, if you're having a hard time remembering to do your homework, you need to get a planner or start typing it into your cell phone or your iPod so that you have a place that you have to go check it regularly to see what your homework is. So, that's a very good question. On 680, you do the whole thing, which sounds like a lot of pages, but look, there's only 4 problems on a page. Okay, so 680, you do top to bottom, the whole thing. 681, top to bottom, even this red one that says got it, you still do it if it's a problem. And then on the last page, top to bottom. So all 3 pages, everything. So don't just do the first problem and then skip to the next page and do the last problem. The whole page. There's 14 problems in total.